All right, today we're looking at notes 9-2, divide radicals, also called rationalize. So there's a rule in math that no square roots or any kind of roots are allowed in the denominator, so we rationalize the denominator, meaning get rid of irrational things. So rationalize, remove the radical. Okay, so what we're going to do today is first simplify if possible, then rationalize if necessary, then simplify again if possible. So looking at number 1, simplify first. Well, yes, I can, because look at square root of 25 over square root of 5. Both of those numbers are under the radical, so since they're both under the radical, you can go ahead and divide them. So the square root of 25 divided by the square root of 5 would give me the square root of 5, because 25 divided by 5 is 5, and it remains in the radical. And then from there, we'll simplify if possible. Well, no, there's nothing I can do to that. 5 is prime, so you're done. Box it up. Okay? Looking at the next problem, square root of 40 over square root of 2. They're both under the square root. That means you can go ahead and divide them if possible, and it is. So square root of 40 over square root of 2 would give me square root of 20, because 40 divided by 2 is 20. And then I can simplify a little bit further. 20 breaks up to 5 and 4. 5 doesn't break up, I drag it down. 4 is 2 times 2. So this is square root. I'm looking for sets of 2, so circle my 2's. So my final answer for this would be 2 square root of 5. Okay? No rationalization has been necessary yet because I've gotten rid of the radical in the denominator. Let's keep going and see if that stays true. So here, square root of 270x to the 9th divided by square root of 3x squared. So always, if possible, first you want to simplify, and I can. 270 divided by 3 is going to give me 90, okay? And I can do that only because they're both under the radical, so that's 90. And then x to the 9th divided by x squared, remember your rule, when you have like bases, you subtract exponents, so that would give me x to the 7th. 9 minus 2 is 7. So then simplify if possible, and it is. 90 is 9 and 10, okay? 9 is 3 and 3. 10 is 5 and 2. And then I have 1, 2, 3, 4, 5, 6, 7 x's. Circle my sets of 2, my pairs. Okay, so there we go. That would give me 3x to the 3rd, okay? And then square root of 10x. And I should have said at the beginning, we're going to assume that all variables are positive today. So if I hadn't said that, then you'd have to put absolute value bars around that x to the 3rd because that's an even index and an odd power. But since today's lesson is so intricate, let's just go ahead and assume all variables are positive. All right, moving right along. So on number 4, we run into a roadblock because when I look at these two numbers, unlike the above problems, 7 divided by 3 doesn't simplify. Can't do 7 divided by 3 without it being a decimal, so there's nothing I can do to simplify first. So unfortunately, we're going to have to rationalize, get rid of the radical in the denominator by a different method. That method, the easiest method, is to multiply by the same thing, square root of 3. Think about that. The square root of 3 times the square root of 3 is square root of 9, which is going to just give us back to 3. So you can't just go multiplying this problem by whatever we want. So the rule in math is that you can multiply by the same thing over the same thing, square root of 3 over square root of 3, because that equals 1. And if I multiply anything by 1, it stays the same. Take 8, multiply it by 1, it's still 8. Take 20, multiply it by 1, it's still 20. So this is not changing this problem, it's just changing the way it looks. Okay, so continuing on. When I multiply, square root of 7 times square root of 3 is square root of 21 over square root of 3 times square root of 3, like I said, is square root of 9, and square root of 9 is 3. So hopefully we can skip this step from now on and just say the same things under the radical multiply together and give me just that number without a radical. Okay, and then of course you want to simplify if possible. There's nothing I can do to either of these. I can't break up 21 enough to let anything come out, and I cannot divide 21 by 3 even though it is divisible by 3 because this is under the radical and this is not. So it's not allowed, so we just go ahead and box it. We're finished. Okay, moving right along. Square root of 5 divided by square root of 2. Again, 5 is not evenly divisible by 2, so nothing I can do there, but I do need to rationalize. I need to get rid of this radical in the denominator. So multiply both top and bottom by square root of 2, okay, which produces on top square root of 10 over, that would be square root of 4, which would just give me 2, okay? So again, you want to, I know you do, I do too, divide this 10 by 2 and give me 5, but I can't because this is under the radical and this is not, so it's not allowed. Nothing I can do to simplify that, so I'm done. All right, number 6. So here, again, this a different situation. Not only is 6 not divisible by 5, but also this is not under the radical, this is, so it doesn't matter. Even if we wanted to, we couldn't. So to get rid of this radical in the denominator, we need to multiply by square root of 5 over square root of 5, which is going to give us 6 square root of 5 over 5. Okay, and then here, if you could, you would divide these two numbers, but they're not evenly divisible. So we're finished and we just box it up. All right, keep going here. So now we've got x squared over square root of x. It would be so nice if we could divide these and get rid of this x, but we cannot because this is under the radical, this is not. So unfortunately, we have to take the step to rationalize. So multiply both top and bottom by square root of x, which would give us x squared square root of x, and then this just x. And then look, we finally run into one to where we can simplify. Both of those are not in the radical, so you can simplify. X squared divided by x is going to give us x. So x square root of x is our final answer on this problem. Okay. All right, moving on to the back. That was number 7. We're on number 8 now. So 5x divided by square root of 15x. So again, nothing we can do to simplify in the beginning, nothing we can take out of the radical, nothing we can divide. So unfortunately, we need to go straight to multiplying by square root of 15x over square root of 15x, which is going to give us 5x square root of 15x over 15x. Okay, and then a little bit more simplification that can be done with this number and those x's. Okay, so what happens with the x's is they completely cancel, and 5 and 15 are both divisible by 3. By 5. So 5 divided by 5 is 1. No reason to really write the 1 on the outside of the square root of 15x. And then 15 divided by 5 is 3. So write it over 3. And like I said, the x's cancel. Okay, I know you want to divide that 15 by that 3, but you can't. That's in the radical, that's not, so we just leave it. Okay, we've approached a problem number 9 that can be simplified in the beginning. So looking at problem number 9, you notice 3 divided by 6 can be simplified, so why not do it? Okay, they're both divisible by 3. This one time, so that would be 1. You don't really need to write it. And then 3 goes into 6 twice, so you'd write 2 square root of 3. Okay, nothing else could have been simplified, not these numbers, nothing else. So what happens when we have a number and a square root? You don't want to get rid of the number per se, you just want to get rid of the square root. So all we need to multiply here is square root of 3 over square root of 3. Okay, make it easier on ourselves. So this would give us square root of 15 over, think about this one, y'all. Okay, square root of 3 times square root of 3 is going to give me 3, and then I've got a 2 here as well. So that would be 2 times 3, which is 6. Okay. So now again, nothing can be simplified here, so you want to go ahead and box it up. All right, looking at number 10. So on number 10, I look at it right away and I say, nothing can be simplified here, nothing can be simplified. The only thing I notice is this is x to the third. This is x to the third, which means I've got, well, 10 is 5 and 2. Y'all should know by now that's not going to break up, but I've got 3 x's. So if you want, since you can simplify and take something out to begin with, go ahead and do it. So that would mean I would have 5x to the 6th over, okay, 3x square root of, this stays 10, and then it would become 10x. And then from there, you can simplify even a little further because you have x to the 6th over x. So this is going to give me 5x to the 5th over 3 square root of 10x. Now that everything's been simplified that I can, now I can go ahead and start rationalizing. So multiply both top and bottom by square root of 10x. Okay, and that's going to give me 5x to the 5th square root of 10x over, remember, this times this is going to give me 10x, but I've got a 3 already here. So 3 times 10x is going to give me 30x. And then I do have a little bit more simplifying that I can do. 5 and 30 are both divisible by 5. 5 goes into 5 once, no reason to really write 1. Okay, and 5 goes into 36 times. And then I've got x to the 5th here and x here. So that's going to become x to the 4th square root of 10x over 6 is the only thing left on the bottom because I got rid of the x on bottom. Okay, and that's it. Nothing else I can do there. A lot of simplification, as you can see today. All right, number 11. So number 11, 32 over square root of 20x to the 3rd. Okay, definitely I look at this denominator and I say, this can be broken up. Let's make it easier on ourselves. So 20 is 5 and 4. Drag down the 5. 4 is 2 and 2, and I have 3 x's. So I want to circle my set of 2's, circle my set of x's. So this is going to become 32 over 2 comes out, x comes out, square root of 5x. Okay, we're making it much easier on ourselves. Now, 32 divided by 2 is going to give me 16 over x square root of 5x. So now I can go ahead and rationalize. So multiply both top and bottom by square root of 5x over square root of 5x. Okay, which gives me 16 square root of 5x over, so this times this would give me 5x, times there's an x that's already here, so 5x squared. I hope you can see from here nothing else can be done. Okay, nothing can be simplified, so I'm going to box it. Okay, as we only have a few more minutes left in this video, I do have probably the most complicated part. Okay, so here's where we get into the fun stuff. So cube roots. So if I've got 5 over cube root of 3, to rationalize this cube root, you need 3 3's. Remember, cube root means you need a set of 3. So instead of just multiplying by cube root of 3, that wouldn't do me any good. Okay, if I multiply this by cube root of just 3, that's going to give me 9, which not enough is going to come out. So when you have a cube root, you need 3 of whatever that number is. So I need to multiply by 2 3's. Okay, and I'll show you what I mean. So here, this is 5 cube root of 3 times 3 over cube root of 3 times 3 times 3. Okay, notice this is a cube root. I need sets of 3, so that comes out. So on top, I go ahead and multiply that back together because nothing's going to come out. So 5 cube root of 9 over 3. Okay, I went through that pretty quick and we don't have much time, but I do want to do another example. Okay, so 2 divided by cube root 16. Okay, y'all, I want you to really think about this. If you want to get rid of this down here, you definitely don't want to multiply by 2 more 16s. That is a very large number. So break this up. Let's think about it. 16 is 4 times 4. Okay, yes, those could go further, which we could do too. But if you already notice a pair here, then that means all we need to multiply by, so I'm going to rewrite this. I'm going to rewrite this as 2 over cube root of 4 times 4, which means I only need to multiply by another 4. Because if I multiply by another cube root of 4, what's going to happen is on top I've got 2 cube root of 4 over cube root of 4 times 4 times 4. Okay, so I've got 3 4's. So all those 4's come out. So I have 2 cube root of 4 over 4. Okay, which simplifies further this 2 and this 4.